Hello, students. So, um, we've been doing all sorts of things with these beautiful set comprehensions where we get sets. And with sets, we know that order doesn't matter and repetition is ignored. You're either in the set or you're not. Um, Suppose we need a situation where we keep track of repetition, like how often something appears, or maybe even simpler, what order things are in, right? As sort of young children, what do we learn first? We learn there's this thing called addition, and order doesn't matter. And then there's this thing called subtraction, and order does matter. So order matters in many things in math. So how are we going to deal with this? Just to check one more time, if I have the set 1, 2, is this equal to the set 2, 1? Absolutely yes. But what happens if I take the tuple 1, 2 and 2, 1? Absolutely not, because tuples do keep track of order. Okay, uh, so um, the thing about tuples is tuples are very fixed. They have a fixed order. They don't allow us to say mutate them in all the ways that we might want to. They have a fixed length. We want something a little more pliable, something like a set that's not as strict as a tuple. And we're going to get that in something called a list. Now, if we want to create a list, we're going to do this just like a set or a tuple, except we're going to use square brackets. And we have our first list. And of course, we could always check, do lists keep track of order? Absolutely. 1, 2, the list is not the same as the list 2, 1. Do lists keep track of repetition? Absolutely. It didn't take away the extra 1 or the 2 when it encountered it. Now, of course, right now you're taking my word for it that this thing is a list, right? How would we want to know for sure? Well, we have the type function, right? Type dir and help. If I want to be sure that something is a list, uh, I just stick it in type, and Python's telling me here, what kind of object is it? Well, it is a list. List is the object that it is. Okay. Well, the next question you might ask is, what can we do with a list, right? So let's see what we could do with it. We know that we have dir, and I could either stick a list here, or I could actually just say, tell me what you could do to this, and I get the same thing. And we're going to get a long list of things, though some of these we could see whether lists, we have this containment business here, and we have indexing. Let's check to see how these might work. Suppose we want to see if something's in a list, like is 4 in the list 5, 6, 7, 8, 9? And it's going to tell me no. But is 5 in the list 5, 6, 7, 8, 9? Well, that is a true statement. 5 is in the list 5, 6, 7, 8, 9. So we have containment. What about indexing? So let's say I have, I don't know, just a list here, and I want to grab the 5th element from this list. Okay, so that's element number 5 if I start counting at 1. Well, Python starts counting at 0. So what I do there is I do just like for tuples, I use a subscript, that means square brackets, and I tell it the number of the element I want. The first element is element 0. The second element is element 1. The third element is element 2, because we start counting at 0. So if I take this list and I say, hey, give me element number 4, that would give me the 5th element in the list if I were to start counting at 1. So let's see what this gives me, and let's see if that's correct. Let's see, this is the first, the second, the third, the fourth, and the fifth, 11. So that is correct. So that's how we can do indexing and containment, just like we can do indexing and containment with tuples, though we can't do indexing with sets because there is no order. Okay, and we have all of these things. Some of these are looking actually pretty sweet, like reversing and sorting lists automatically built in, but I don't want to get lost in all these different things that we can do to lists. One thing though I will mention is we have add, so that's telling me that I can take a list plus a list. So like I can do this. Let's see, what's going to happen if I do this? So you might think, okay, well, we could treat lists like vectors in space, right? 2 dimensions. If I have the vector 1, 2, and the vector 3, 4, what would you do? You'd add the 1 and the 3 in the first spot, and you'd add the 2 and the 4 in the second spot. But these aren't vectors. I mean, they're not even in the same number of dimensions if we think about it like that. So what could Python do here? Well, let's see. You know, one thing about Python that you don't have to worry about is you don't have to worry about it blowing up your computer just because you decided to have it see what adding 2 lists will do, right? You can try things, you can experiment, you can get your hands dirty and try things in Python. And I see here what add does now. What it does is it just concatenates the 2 lists together into one longer list. So now I know what add does for lists, but don't be afraid to experiment with lists here. Okay, so we have tuples, we have sets, and we have lists, and we can use these to store information. Tuples and sets are ordered, so we could store, let's say I need the 1 to come before the 2. I could store that in a tuple, or I could store that in a list. So think about it for a second. Are these going to be the same? Well, a tuple is not a list. These are different objects in Python, and we can do different things to them. So Python is going to tell me, no, these are not the same. The thing on the left isn't even a list. So these are different. So even though they both have the 1 and 2, they are not the same. Okay, but there's something we could do. We can actually convert between lists, tuples, and sets using 3 functions. Set, list, and tuple. So let's see how that works. Let's say I have a tuple and I want to turn it into a list. So I could say, hey, take this tuple and turn it into a list for me. And it does it. Or I could say, take this list and turn it into a tuple for me. And Python does that as well. Let's say I want, hey, take this set, 10, 20, 30, 40, and turn it into a tuple, into a list for me. And notice something, the order. But did it screw up? No, because the set itself had no order. So Python is just going to sort of do whatever it wants. Hey, you gave me a set. The set had no order. So if you want me to turn this into a list, I could just put them in any order I want. Now, once that 40 goes in the first slot in the list, that's going to be fixed. For instance, if I turn this into a tuple, that 40 is still going to be in the front because now with a list, we do have order. But we did not have order with a set. So there was no reason for us to expect that when we turn this set into a list, that they would be in the same order that we wrote them in when we wrote them up as a set. However, going from lists to sets, we don't have to worry because it doesn't matter what order they're listed in. What we get is an orderless object. Python might write the 10 in the front, but there is no front, there is no back. Sets simply don't have order, and we don't have to care what order a number appears in if we're looking at it in a set. Tuples, yes. And similarly, you can go back and forth between sets and tuples. For instance, let's, I don't know, turn this tuple into a set, and I get the set 1, 2, 3. So those are some very useful functions. As a matter of fact, we can check to see if something has repetition by turning it into a set. For instance, len, one of our favorite functions, it works on lists. Len of this list is 3. But if I check the length of the set of this list, I get 2. So I can actually use length to check for repetition. And that's going to come in handy in some instances as well.